Okay, so in this example, we're going to be talking about evaluating functions. Now, this is pretty straightforward. It's literally just substituting into variables. But if you don't know what function notation is, then you're going to be very confused on what's going on here. So before we start these examples, let's first talk about function notation. And I have that written down here. And you can see that I have a statement saying f of x equal to x right here, okay? Now, this is the same thing as y equal to x, but we write it in function notation so that we can identify that what we're talking about here, the polynomial, is in fact a function. And we know that a function simply means for every x value, there's exactly one y value. So for example, if I were to write this function as y equals x, if I didn't know any better, I wouldn't know if this is actually a function or not a function. But whenever you write something in function notation like you have here, you are going to be immediately identifying that it is in fact a function. Okay, so again, for every x value, there's exactly one y value. So when you're evaluating functions, it's really simple. And let me go ahead and get rid of this stuff here. All you're doing is you have an input right here, and your output is this whole part right here, f of x. Okay, so for example, I could say f of 2. And what that's telling me to do, it's saying wherever I see an x on this function f of x, I have to plug in a 2. So here's my polynomial x, my function, right? So there's my x. If I were to plug it in, that means that f of 2 is equal to 2. I'm just plugging it into x. So it's pretty straightforward. Let's go ahead and take a look at these examples now. So here's our first example. And again, you could write it however you want. The first example I gave you was f of x. This is called g of x. I mean, you can write it however you want. So again, my output is going to be g of x, and my input is going to be x. So remember, your input is always going to be your x values, and your outputs are always going to be your y values. So in other words, you're really writing it as x, comma, g of x, where again, this right here is my x, and this g of x is my y, okay? That's what's actually going on here. So again, wherever I see a x, I have to plug in a 6. That's what it wants me to do, g of 6. So I'm going to write here g of 6, and I'm going to set it equal to 2. Now here's my x. I'm going to put it in parentheses. I'm literally just going to substitute. So substituting in, I get a 6 here, and then minus 3. And then all I have to do is solve. Now this part over here, you're just going to leave it as is. You're going to include that in your final answer. So don't do anything on the left-hand side of the equal sign. I'm going to rewrite it as g of 6 equal to 2 times 6 is 12 minus 3. And then finally, 12 minus 3 is going to give you 9. So I get g of 6 is equal to 9. So this is actually a point on this function. In other words, this is my x value right here, 6, and my y value is going to be this part right here, 9. So I went ahead and did an input of 6, and my output was a 9. So g of 6 is equal to 9. Okay? All right, let's try another example. So here's my next example. It looks a little bit more challenging. I have absolute value, but same thing. They want us to find f of 6 here. So I'm going to write f of 6 equal to, and then I'm just going to rewrite what I have on the right-hand side. I have negative, and then absolute value. Here's my x. I'm going to plug in a 6, plus 4, absolute value bar, closing it, and then plus 5. From here, all you have to do is evaluate it. So doing inside absolute value first, I get 6 plus 4, which is 10. So f of 6 is equal to negative, and then the absolute value of 10 plus 5. Well, we know that the absolute value will always be positive, so the absolute value of 10 is 10, but then I do have this negative on the outside, so it ends up being a negative 10. Okay, so now I have f of 6 equal to negative 10 plus 5, and then when I combine those like terms, I get negative 5. So f of 6 is equal to negative 5. Done. Here's my final answer right here. So again, my input was a 6 and my output was a negative 5. So in other words, you could actually write this point as 6, comma, negative 5. Again, input right here, and here's my output right here. Okay? All right, let's try 2 more examples. Here's my next example. Here I have a quadratic, but same thing, f of x. So they want us to find f of negative 1. So I'm going to do f of negative 1. Wherever I see an x, I plug in a negative 1. Now be careful, you have a negative here followed by an x squared. So I'm going to put equal to negative, and then in parentheses, I'm going to put that -1. That's very important. Make sure you separate that negative from that variable, okay? And then I'm going to square it, and then plus 4 times a -1, because I have another x there, and then plus 1. So taking care of it, we know that we have to do the exponent first. So I'm going to do -1 squared. That will give me +1. But then I had this negative here, so it becomes -1. So I'm going to rewrite the problem. I have f of -1 equal to, and again, we said that this whole part right here is going to end up being a -1. So I get -1, and then 4 times a -1, I get -4, and then plus 1. So look here, it's all addition and subtraction, but I have a -1 here and a +1 here. They're going to cancel each other out. I'm just left with -4 here. So my final answer is going to be f of -1 equal to a -4. Done. Okay, there it is in function notation. And we just went ahead and evaluated that function. All right, let's try one more example. So here's our last example. This one we have t of a. Again, a little bit different than f of x and g of x, but again, you can write this however you want. So in other words, my input here is going to be a, my output is going to be t of a. And they want us to find t of 3. So I'm going to write t of 3. And so again, wherever I see an A, I'm going to plug in a 3. So equal to, here's an A, plug in a 3. And then 7 minus, here's another A, plug in a 3. Right, squared plus 5 times A, so I have to plug in a 3 there. Okay, and then times 4. Okay, all we have to do is evaluate and then we're done. So I'm going to say here t of 3 equal to, so we have to take care of what's inside parentheses. Again, just following PEMDAS, your order of operations. So I have to do 7 minus 3 first, and that's going to give me 4. And then I have to square it. So I know that 4 squared is going to be 16. So I'm going to rewrite it as 3 times 16 plus 5 times 3 times 4. Okay? And now all we have to do is multiply and add together. So if I do 3 times 16, I get 48. So rewriting it, I get t of 3 is equal to, this will give me 48, plus 5 times 3 is going to give you 15, and then 15 times 4 is going to give you 60. So plus 60, and from here, I just have to do 48 plus 60, that's going to give me 108. So t of 3 is going to be equal to 108. Okay, that is completely done, okay? And that's it. So that is how you evaluate functions. It's pretty straightforward, but you do have to understand function notation. Just remember, when you see function notation, it's really like y equals, but we write it in function notation. That way we can identify that the polynomial is in fact a function, meaning for every x value, there's exactly one y value, okay? So that is it. I hope that you gained something from the video. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.